In every corner of the world, from the busiest streets of New York to the quiet villages of Pakistan, one universal sound connects humanity: the satisfying crunch of a potato chip. But behind this simple, addictive snack lies a massive global industry, a place where machines never sleep, conveyor belts never stop, and billions of potatoes transform into golden slices every single day. Today, we take you inside this hidden world, a world of farming, technology, food science, quality control, and high-speed automation. This is the complete 40-step journey of potato chips manufacturing, from soil to supermarket shelf. Let the journey begin.
The journey begins long before the potato ever reaches a factory. Potato chip manufacturers partner with contracted farms across the country. Only specific varieties like Lady Rosetta, Hermes, Atlantic, and Lady Claire are chosen because they have low sugar levels and perfect starch content for frying. These premium potatoes are planted, irrigated, monitored, and grown under strict conditions to ensure consistent size, texture, and taste. Once matured, massive harvesting machines carefully lift potatoes from the soil without damaging them. The potatoes are gathered, loaded into crates, and transported to temporary storage units. From the farms, hundreds of tons of potatoes are transported daily to processing plants in refrigerated or ventilated trucks that prevent heat damage.
At the factory entrance, quality control teams check the load for defects, size uniformity, soil content, and freshness. Any rotten or soft potatoes are immediately rejected. Every truckload is weighed on a digital industrial scale. The data, including farmer name, date, weight, and batch code, is logged into the factory system. Hydraulic lifts unload the potatoes onto wide conveyor belts that move them toward the washing area. Powerful air blowers and rollers remove loose dust, stones, and dry soil before washing. Potatoes enter huge rotating drum washers where high-pressure water jets clean them thoroughly. The friction of the drum removes stubborn mud. A built-in density separator removes stones and heavy foreign materials using water buoyancy and sensors. A final high-pressure spray removes microscopic dirt. Clean potatoes then move toward the electronic or manual sorting line.
The approved aluminum billets now enter the forging section. Massive furnaces heat them to over 500 degrees Celsius, softening the metal without melting it. Automated hammers then compress the aluminum with thousands of tons of pressure, increasing its strength by aligning its grain structure. Forging gives Lamborghini structural rigidity, the kind that lets the car slice through air at insane speeds without flexing. Once forged, the metal must be shaped with absolute precision. Lamborghini uses 5-axis CNC robots capable of cutting aluminum to tolerances smaller than a human hair. Each frame component, from the front crash beam to the side rails, is carved with mathematical perfection. The machines use aerospace software to ensure zero-dimensional error. Every curve, every angle, every mounting slot is intentionally designed for extreme aerodynamics. Now the cut components arrive at the main chassis line. This is where the skeleton of a Lamborghini is born. Robots and humans work together, aligning structural beams with millimetric accuracy. The assembly fixtures use laser guides to ensure everything fits perfectly.
Lamborghini does not use traditional welding. It uses high-precision robotic laser welding. Thin beams of concentrated light melt the metal with surgeon-like accuracy. This creates welds that are lighter, stronger, and cleaner than conventional welding. The chassis becomes a single unified structure, rigid, aerodynamic, and incredibly durable. One of Lamborghini's secret weapons is forged composite carbon fiber. Unlike regular carbon fiber sheets, Lamborghini uses chopped, randomly oriented fibers compressed under heat and pressure. This creates a material that is extremely light yet unbelievably strong, perfect for supercars that demand extreme aerodynamics. The carbon fiber sheets are now shaped into Lamborghini's iconic body panels. They are placed into molds, vacuum sealed, and cured in massive autoclave ovens at 135 degrees Celsius under extreme pressure. This process gives each panel its strength, smoothness, and aerodynamic.
The forged engine block now enters Lamborghini's ultra-high precision CNC machining center. Here, 5-axis robotic cutters sculpt the block into its final form. Each cylinder is bored using diamond-coated tools, ensuring mirror-like smoothness inside the cylinder walls. This surface must be perfect, because inside these chambers, explosions will occur thousands of times per minute. Any microscopic flaw could destroy the engine at high RPM. The machining robots cut oil channels, coolant pathways, and mounting points with sub-millimeter accuracy. This is not just metal cutting, this is surgical engineering. The cylinder head is where the breathing of the engine happens. Air flows in, exhaust flows out, and combustion timing becomes a dance of precision. Lamborghini machines the cylinder head from a single aluminum casting. Robots drill exact holes for intake ports, exhaust ports, spark plugs, and fuel injectors. Then hardened steel valve seats are.
Unlike ordinary cars, Lamborghinis use a dry sump lubrication system. There is no oil pan. Instead, oil is stored in a separate reservoir and pumped under pressure to every engine component. This prevents oil starvation during.
At this stage, the partially assembled Lamborghini frame is moved into the laser alignment chamber. Here, ultra-focused industrial lasers measure the chassis down to 0.02 millimeters. Any misalignment, even the width of a human hair, can change the aerodynamics, speed balance, and handling. Robotic arms gently nudge the frame into perfect alignment. This is the moment when the skeleton of the Lamborghini becomes mathematically flawless, ready for extreme speeds. Now the monocoque, the central safety cell, undergoes reinforcement. After leaving the fryer and passing through the air blast section, the chips enter the cooling tunnel, a long stainless steel chamber where temperature begins to normalize. This stage is essential. If chips are flavored while still hot, the seasoning melts instead of sticking. Controlled cool air flows evenly from top to bottom, bringing every chip to the perfect seasoning temperature. Once cooled, the chips move into the large rotary seasoning drum. Here, powdered flavors like salt, masala, cheese, chili, or barbecue are evenly sprinkled through nozzles. As the drum gently rotates, the chips tumble inside, ensuring every chip receives a perfect coat of flavor. This step is responsible for the signature taste customers love. In this stage, the flavored chips pass over an intelligent sorting system. Cameras and sensors check the size, shape, and color of every chip. Perfect chips continue forward, while burnt, broken, or irregular shapes are removed instantly by air jets. This guarantees that only uniform, high-quality chips reach the packaging line. The perfectly sorted chips now move toward the automatic weighing station. This advanced system measures the exact weight for every packet, whether it is 15 grams, 35 grams, 100 grams, or family size. Sensors detect even a 1-gram difference. If the weight is short or excess, the machine automatically adjusts the number of chips. This guarantees consistency across all packets. Before sealing, each packet is flushed with food-grade nitrogen gas. This removes oxygen from inside the pouch. Nitrogen prevents chips from going stale, keeps them crispy, and protects them from breaking during transport. This is the reason a chip packet feels puffed. It's not air, it's nitrogen.
The packets now pass through the heat sealing unit, where two heated jaws press together and create an airtight seal within milliseconds. This seal keeps freshness locked inside and blocks moisture from entering. A strong seal is essential for long shelf life. After sealing, each packet undergoes a rapid inspection where sensors check for leakage, sealing defects, and irregular shapes. Any packet that fails the test is pushed aside instantly. Only flawless packets are allowed to move ahead. A high-speed inkjet printer marks each packet with essential information: batch number, manufacturing date, expiry date, and plant code. This ensures traceability and safety for consumers.
After inspection, the sealed packets fall into a carton filling station. Here, a robotic arm arranges packets neatly inside large boxes according to quantity: 24-pack, 48-pack, or 100-pack cartons. Filled cartons move to the sealing section, where heavy-duty tape machines seal them shut. A barcode label is applied on each carton for warehouse tracking and logistics management. A final round of manual and sensor inspections ensures that only perfect quality chips leave the factory. The sealed cartons are transferred to a climate-controlled warehouse, where temperature and humidity remain stable to protect product freshness. Finally, the cartons are loaded onto trucks and sent to markets, stores, and distributors nationwide, ready for customers.